Hello and welcome from the Deep Space 8K, and today here we see the premiere presentation of the Translucent St. Stephen's Cathedral project. And my name is Roland Haring, I'm the Technical Director of Ars Electronica Future Lab, and with me here is Nikolaus Dudnica from Riegel Laser Measurement Systems, who did the laser scans that were needed to create this project, but also Wolfgang and Franz Zehetner from the Dombauhütte Wien, St. Stephan, who responsible to maintain this cultural heritage of St. Stephen's Cathedral, and who are really the experts to explain us even more details about what we see here and what we can explore in this very special presentation. And we started already with the presentation a few minutes ago here, so we would now proceed, and please enjoy.
Okay, so we are right in the St. Stephen's Cathedral at the moment. We're looking here into the choir, and Mr. Zehetner probably can tell us a bit what we see here, the big altar, the St. Stephen's altar.
That's one thing that is strange for some art historians, that the mainly Gothic Cathedral of St. Stephen's has a Baroque high altar, and some criticize that this is a mixture of styles, and nowadays many also experts think that this is so special as exactly for Vienna, which always was a melting pot of cultures and natures, and of course of periods, that in this cathedral you can see concentrated the centuries. And here on the right side also small Baroque altars, but the architecture of course is Gothic.
So for all the online viewers now, we turn around and you can see now the main nave of the St. Stephen's Cathedral in Vienna. When you look back, this is the entrance door.
Just actually now we have already, and it should be opened again on the 4th of October, the organ, which now covers all the backspace, has been rebuilt in the last years, and here this is one of the seldom views where we can see this stone arch in back that has been built to keep the two western towers apart so they wouldn't incline together.
So we were talking about this before, that the western towers are still in Romanesque style, but then this view into the ceiling opens up a typical Gothic structure with the cross-ribbed vaults here, and this
a very special system of vaulting, which was originally planned also to show the lines of the weight power from the top of the ceiling finally going down into the ground.
You could actually call this like a skeleton technique of building.
Sort of, yes.
Yeah. So, and also some information for the online viewers. We can fly through the scan like this. And we were in a bubble before with high resolution view, a 360 degrees view. By the way, I'm controlling our flight here with an Xbox controller. And let's take a look at the outside now. We're flying.
But here you really feel the Gothic structure, whereas the Baroque pictures are not visible.
So, and through the Romanesque part now, and then you can see even the buildings surrounding St. Stephen's Cathedral. So now we're outside, and now I can again display these points. You see there's blue points, or over there is a green one, and whenever I want to change my position into another high-resolution bubble, I just target this point here, and we fly over there, and we will have the high-resolution 360-degree view then. Yeah, and now we're looking straight at, I would say, really the landmark of Vienna, the South Tower of St. Stephen's Cathedral. Here it is. 136.4 meters tall, am I right? And
it's not only height, it's considered to be the most beautiful Gothic tower, at least in Vienna.
in the world.
We think so.
So with the typical Gothic decoration, everything is kind of striving to upwards to the sky. And just compare it to this tower here. This is the Romanesque structure still, totally different. And obviously the older part of the cathedral anyway. Yeah, and quite outstanding also is St. Stephen's roof. And one very special thing is we can, through this transparent laser scan, now also take a look here in the attic. We're going to look for some points with high resolution pictures, like, let's take this one. Yeah, and the construction of the roof here is now made out of metal since after World War II. And maybe Mr. Zehetner can tell us a bit more about the whole structure.
Of course, right now, since all of us are still aware of the big catastrophe in Notre Dame in Paris, we can really treasure what they decided in 1945 when almost many parts of Vienna really were destroyed. They were able to rebuild this roof of the cathedral in short time. The first measurement was to make a concrete layer, which you can see on the bottom where we can move now, which was not so before. And then they built the steel structure. And the steel construction is only half the weight the wood structure had before, and the rest of the weight is now for this concrete layer on the floor of the roof. And this structure is really well done. It was, by the way, constructed by Föst, together with Wagner Biro, the Linz company. And it's one of the parts that doesn't really make problems for me as the architect.
So I would suggest that we go a bit deeper now into the background of the whole project. How is this technically done? And this we're gonna explore now with a presentation. How is it technically done, and why is this important anyway for the preservation then also?
Thank you very much. Thank you very much for the invitation. My name is Nikolaus Stunitzka from the company Riegel, and Franz Zehetner will speak about the Dombauhütte afterwards. We give you a small introduction in our companies and about the laser scanner. This is the product line of our company. It's an Austrian-based company with more than 230 employees, located in Horn, about 80 kilometers from Vienna. We are manufacturer of terrestrial scanner, airborne scanner, mobile scanner, and UAV scanner, so also on the drone. If you look to the terrestrial scanner, it's millimeter accurate, and all the other kinematic scanning systems are centimeter accuracy. The scanner itself, it's only one slide, has a range of up to 800 meters, a precision of 3 millimeters, and very specially we can take 50 scan position per hour, and all the scans are registered, merged together inside of the laser scanner. A single point cloud has a hole underneath and on top of the laser scanner itself. What you see is a gray-colored so-called reflectance, and we have more than 22 million points within 45 seconds, together with 5 to 8 high-resolution photographs. These photographs allows us to colorize the point cloud, and we move the scanner every minute to the next scan position. And so it's possible to merge all these scan data together. The whole project has more than 1,000 scan positions. And how to merge it together is we simplify the point cloud in the scanner to a so-called voxel file. In each voxel, we have a plane. Each plane has a normal vector, and this data allows us with a special algorithm to merge all these scans together. 1,000 scan positions gives us a picture, for example, from the top of the cathedral itself, the catacombs underneath, the roof on top, and also the Stephansplatz, the square around St. Stephen's. If we go a little bit more in detail, this is a view never could see in the past. So it's the church underneath, or the catacombs, together with the internal room of the cathedral. The point cloud, the so-called 3D point cloud, actually it's reduced already, looks like this, and you can see on the top or on the right side how many scan positions are necessary to reduce the so-called scan shadows. I was quite impressed what's underneath the Stephansplatz, the square. You see on the left side the garage, and if we jump into the data, so I go forward, backward, forward, and you see how many rooms are inside the cathedral, outside the cathedral, and it's a lot of history of all these rooms. With this side view, it's an orthogonal side view of the cathedral, I hand over the microphone to Magister Franz Zehetner.
Thank you. In this 3D model of the cathedral, you can see both the north and the south facade, and you can see some differences and irregularities. For example, a slight angle between the axis of the nave and the choir. Another thing you can see on this model is the scaffold on the south tower and on the south facade. Scaffolds are necessary for the maintenance and restoration of our cathedral, for which the workshop is in duty. Active since the Middle Ages, 20 people are addicted to the preservation of our cathedral, and this permanent work on the cathedral gives us a very intense knowledge of the structure and the problems of the cathedral. Our masons still use the traditional techniques known since and practiced since the Middle Ages. Here you can see a capital copied by one of our masons after a damaged original. On the other hand, we are active in research in partnership with some universities and also in EU-granted projects to enhance the possibilities of our restoration work. Plans were always crucial for building, maintaining, and preserving historic buildings. In the Middle Ages, they had plans for details, but also for great structures as the steeples and towers of the cathedral. Measuring equipment was very important for the Masons. So not hammer and chisel are the symbols of the medieval masters. It is the angle and the circle, as here in the self-portrait of Master Anton Pilgram, one of the cathedral architects of the Middle Ages. When people restored Gothic cathedrals in the 19th century, they had to complete some unfinished parts. Here, for example, on the south facade, but essential were intense studies of the completed parts, as we can see on a plan, which was the pattern for the completion, which was not a totally copy of the finished things, but it was just an inspiration to do independent work. Nowadays, we concentrate on the preservation and not in the copying of historic materials. In some times, however, in some cases, it's inevitable to make a copy of a totally destroyed piece. For example, here a tabernacle, which was made by craftsmanship, but the plans and the structure was constructed in a 3D CAD system on a computer. To come to the whole structure, here is a plan of the western facade based on a photochrometric plan made in the 1990s. It shows the different varieties of limestone, and the different varieties have different properties in physics, chemistry, and decay, and so they have to be treated in a different way. We also map our activities on plans like that to preserve the activities and the knowledge about our activities to future generations. This is the basis for this planning work, the 1:50 scaled photochrometric plan, but some parts are not visible here because it shows only the main views of the cathedral, and we are limited in our studies of the structure to the main directions. Survey plans are essential for the documentation of the state of a cathedral. St. Stephen's was damaged in 1945, but as we know, also in peaceful times, the cathedrals are vulnerable and endangered. We had a first 3D laser scan in 2005, and we got some very interesting studies on the geometry of the vaults. Here you can see the vault of the choir, a very ordinary cross-strip vault, and you can see in some parts the axis of the cylinders and cones the vault is constructed of are not regular. In every bay, the direction of the axis differs. So the towers, which have a very, very high weight, they deform the fundaments of the cathedral and deform the walls. Here is a section based on the actual scan, and it shows very, very impressive, in a very impressive way, the cathedral from the catacombs to the top of the roof, and it shows also the structure of the vault and other static structures. And to close with this view from the western side or the eastern side, we can compare the different parts of the roof, and we can also see the differences in the western towers. If you compare them, they seem symmetric, but they differ in very, very many ways. Of course, that was known to specialists ever before, but now the visualization shows it for everyone and is accessible for everyone. Thank you for your attention, and now back to the amazing 3D point cloud.
So, and here we're back underneath the roof in the attic of St. Stephen's Cathedral. And what is quite interesting, you have seen this also on the plans, the roof is extremely steep, isn't it? Why is this?
That had historic reasons that go back to the 15th century, that others, in difference to some of the big cathedrals in Europe, St. Stephen's originally was not a bishop's church, not a cathedral, it was a public church, and the type of this church was a hall. And the hall does not have a higher central nave than the side naves, and so they had Vienna had the biggest roof of all the cathedrals, and still has. And since in Vienna we have a lot of snow also, it was necessary to build this large roof that covers all the naves under one, as we say in Vienna, get everything under one head. The snow must not stay on the roof. So they built it so steep that whenever, until today, we have more than 8 millimeters of snow, the snow glides down and the roof is free.
That's interesting, of course, yeah.
And one reason why this large, more than 10,000 square meters of roof for the, at this time, not so big city, it would have formerly killed the whole silhouette, just a red area of red bricks. So they invented this nice pattern to make this huge area looking nicer.
So, and here we are now in front of the sepulchre of a very famous emperor.
This is Emperor Frederick III, who reigned the Holy Roman Empire of German nation, as it was called, for almost the whole 15th century. And he is buried in here in the cathedral inside of one of the most outstanding sculptural works of the 15th century for all Europe.
He actually died in Linz. So the last 3 years of his reign, he was here in Linz, and his heart is buried in the parish church here in Linz, and this is the rest of Frederick III.
And here you can see the structure of the hall, as I said, not a cathedral form, a hall, where you can see through the naves the whole room.
So, and I will just jump from bubble to bubble now, where we have these high-resolution views then. And where are we now?
Now we can look through the walls. The central motif is in the sacristy, and we see through the walls into the cathedral.
So actually this is not transparent, of course, in reality.
No, that's
no, this is the sacristy.
Fantastic thing of this laser imaging.
Yeah, this is really quite impressive because you get a way better understanding of the structure of this cathedral through the transparency here.
That really gives us a new way of understanding the structure, which was a fantastic invention in around the 1200s.
Again, here a view into the vaults, and when we turn around, you can see the different styles. As of course, as I mentioned in the beginning, yeah, it's about more than 500 years, the history of building St. Stephen's Cathedral. It was firstly consecrated in 1147. So, and now it's time to say goodbye to our online viewers. And by the way, this 3D scan of the St. Stephen's Cathedral will be in our regular program from now on, and if ever you have time to come to Linz, you can visit us at the Ars Electronica Center, Deep Space.
Yes, and I would also like to thank you very much for the contribution to this project. Otherwise, it would not have been possible to show this today. It's very important to have this really, this highly valuable data, and also not only to use it for restoration, but also for the presentation of this wonderful church. So thank you very much for coming to Linz today, and also for the explanations.
Thank you.
Thank you.